think sets may be the easier one for me to talk about. So let me see if I can get a notebook here.
I think I've mostly got it. I'm just, I don't think I quite understand like the use case and whatnot, like for sets, like versus some like tuples.
Okay. So tuples are harder to explain. So just because well, actually, maybe call this data structures. So lists, I assume, are pretty straightforward. It's when you have to have a sequence of things. Order might be important, like the order that they occur might be important to you. Like you need to know who's the first person to get in the line or whatever. Tuples are very much like lists. So tuples are kind of laying things out in a row. Difference is tuples cannot be, you can't modify a tuple. So if I have a list, which has 1, 2, 3, I can always append to that list. I can delete the second element out of the list and we get the list and it's been modified, right? So I appended a 4, I removed a 3, and that's all fine. So tuples, if I have a tuple 1, 2, 3, I cannot append. There's no method append. I can't delete out of the tuple. I cannot, if I want to do anything like create another tuple that has some of the elements from the previous tuple, I can slice it. So if I say like tuple of, say, 1 to 3, then that gives me a new tuple, right? Put that in caps. One of the weird things that you can do with tuples is you can say, well, here's my list, right? I could say, give me another tuple, which is 1, 2, and the list. So what I cannot modify anything in the tuple directly, but what I can do is I can modify, I can mutate the objects that the tuple contains. I guess that's what I'm trying to say. So I can't change which objects it's pointing to, but I can, so if I say tuple 2, that's my list, I could append a 5 onto it. And that's just fine. Tuple lets me modify or mutate the objects that are inside of it, but it does not let me change which object it's pointing to inside of it, right? So it's kind of like I can go in and muck with the things inside the box, but I can't change which things are inside the box, right? I can't take a thing out of the box or put something into the box. Does that make sense for tuples? You're muted.
I think so. Okay, so like what would like the use case of tuples be? Like I'm just trying to like understand like how like these would be used or like what they would be used in.
So tuples are commonly used, well, they're used internally in Python a lot of places where you, like it's used to represent the arguments to a function. When you call a function with like 3 arguments, Python will create a tuple with those 3 values and pass it to the function, because those should never be modified. You can't change how many arguments you pass to a function once you've called it. As far as programmers using them, it doesn't happen that much. But so one of the things that you can use them for is if you wanted to do something like coordinates. So if you're doing graphics programming, you might use them for XY coordinates, something like that. Things that go together that it never makes sense to change the length of that, right? If you're doing a 2D graphics program, you never need more than X and Y locations. You never need to add a 3rd dimension. That'll just break things. another place where it's used sometimes is occasionally you'll have a function that you want to return 2 items from. So I'll call this so let's say I've got a function and don't so this function already exists in the built-ins, so don't build it yourself. Okay, so I'll call this div mod, and I'll say A and B, and what I want to do is return the actually perform integer division returning quotient and remainder. All right, so sometimes you want to actually do 2 values. This is the simplest one to think about. So I could say quotient is equal to A divided by B. Actually, this is my integer division in Python. I'll make sure that I don't have any fraction part. And the remainder is going to be A mod B. And so I can return quotient and remainder. And so the comma right there puts that into a tuple. You don't have to put the parentheses around tuples. It's optional when you're declaring them. But just returning them with commas like that makes it into a tuple. So if I say a div mod, say 15 and 7, then that gives me 2 with a remainder of 1. Right, so that will build a tuple. Now, most of the time that tuple is immediately going to be destroyed because what I want to do is something like result quotient result remainder is equal to div mod 15, 7. And you can do that. You can do multiple assignments on the left-hand side. And if you have a sequence on the right-hand side, it'll automatically pull things out in the right order. All right, so and now I can look at result quotient, result remainder. Well, not remo. There we go. Okay, so sometimes people will use them to return multiple values from functions. This would all work the same way if I put square brackets around it. But why? Right? Lists are a little bit heavier weight. They use a little bit more memory, so people normally don't do that. So if you can't ever think of a case in which you'd want to append to something, a tuple might make sense to use. Okay? So does that clarify lists and tuples a little bit? You're still muted, or you muted again.
Yeah. I think I get it better, yeah.
Cool.
And then with sets and dicts or dictionaries, where did I have it?
So a dictionary is the much more commonly used one. So a dictionary is when you want to look up values by their keys. So if I have a dictionary, I could do something like this. Right, so there's my telephone directory. So if I want to look up Jenny's number, then I can look it up like that. Right, okay, so at least one person's got his camera on and recognizes the number. So cool. Dictionaries are mutable, so I can I can delete them out of there, although Jenny should really be an immutable value in this dictionary. You should never be able to actually remove it. So I can say things like delete tell of Jenny, and then tell is now an empty dict again. Right, so that's the main use case for dictionaries.
Okay.
Now what sets are, when you want to quickly know whether an item is contained in a collection. So let's say Or, well, actually, that's one of the use cases. So one of the ways that you can use sets is to deduplicate a sequence. So let's say I've got a sequence here. And it's actually, this is Stooges, right? So I'm going to do this with a funny little way of doing it. So Larry, Mo, Curly, Shemp, Mo, Curly, Larry, and then I'll split that. It's just a short way for me to build a list. So I'm doing split to split them on white space, so I get a list of strings. Now there's only going to be 4 Stooges, despite the name of the show. So the length, though, of this is 8, right? So if I wanted to turn this into a deduplicated list of Stooges, I could say set of the Stooges. And the thing about sets is they only allow a single instance of any item that they contain.
Oh, okay.
Okay, so this is the deduplication. Now, one of the problems with this is order is not preserved. Notice that Curly comes first now, and then Larry, Mo, and Shemp. So it's kind of a weird order.
Alphabetizes it.
Well, it's not necessarily going to alphabetize it, but it might.
Yeah.
Okay, so
yeah, I noticed that in like a few examples and whatnot, or like also in like when I was like experimenting.
And one of the things that you can't do is I can't get the first. Wait, I'm not supposed to. Oh, sorry. This is. I'll call this S Stooges. There we go. Oh, and that time no, it still looks alphabetized. I cannot look up things by their position inside sets because you shouldn't really care about what position it is in the set. That's the idea, because Python might move things around. What you can do very quickly is you can say is Curly in Stooges, and that's true, right? I can do the same thing with a list, but it's slower or potentially slower. So we can actually, and this is a really small collection, so it won't show much of the difference, but we can look at the difference here. So this will tell us the 2 timings. It'll run it several hundreds of thousands of times, or maybe millions. Okay, so 51 nanoseconds for the set, and 110 nanoseconds for the list. So it's twice as long. And that's for a really small one, where in fact in the list, Curly showed up as the 3rd item. So sets are used for, they're used for the deduplication. They're used for determining whether you've seen something or not. And then there's one other use case, which is in synchronization. So let's say I've got two sets of keys from 2 databases, and how to, I'll call it A and B. Actually, I'll call them source and dest. How to determine what to do, which SQL, and we haven't really talked about SQL, but I think it'll be clear what I'm doing here for each item. And so could it be an insert to dest, an update in dest, or a delete from dest? All right, so let's say I've got source is going to be 1, 2, 3, 4, 5. Dest is going to be 2, 4, 7, 8, 9. Right, so I know that I need to insert a 1, right, because it's in the source, but it's not in the dest. I need to update a 2 because it's in both, and I need to delete, I need to insert a 3, update a 4, need to insert a 5, I need to delete 7, 8, and 9, right, because they should be synchronized. So what I do is I say keys to insert are the things that are in source, but not in dest. Keys to update is all the things that are in both. So that's source and dest. And keys to delete is all the things that are in dest but are not in source. All right, so keys to insert is that set. Keys to update is that set. Keys to delete is that set. So that's kind of a cool little thing that we can do with sets, and that's where we use it a good bit in especially the health drive application, because that's exactly what we're doing. We're synchronizing between things in point-click care and things in health drive's database, and we need to know whether we need to execute an insert, update, or delete statement. And technically, we don't ever delete. We just set a flag that says it's been deleted, but yeah.
Okay, cool. Thank you.
Yeah, no problem. Does that make sense as in terms of what we would use all these different built-in data structures for?
Yeah.
Cool. Any questions from anybody on lists, tuples, dictionaries, sets, or any of the others?
No, I'm good.
You could talk about default dicts while we're at it.
Okay, yeah, so in the collections module, we have a few extra things. So the list, sets, dictionaries, tuples, these are all built into Python, so you don't have to do any kind of an import to use them. So the two that are most, or there's two that are kind of interesting here inside the collections module. There's default dict, there's dec, and actually there's three that are useful, and a counter. So sorry. Oh, come on. Did I made too many UEs there. Okay. So default dict So a default dict is a dictionary that never raises a key error. So normally if I've got a dict and I try to look up something that's not in the dict, no such key, I get a key error. So what happens with a default dict, I'll call this DD. I have to give it some kind of a function. So I'll call this my default factory here. Oh, whoops. Because I have to pass a function into a default dict. And I'll define that function in just a second. And let's just always return 8675309. Okay, so now when I try to look up no such key, whoops, sorry, DD, it's going to call my function to give me the value that corresponds to that key. It's also going to modify the default dict so that it now has no such key in it. So it will always call this function, whatever function you give it, it will call if the item is missing. Now, if the item's not missing, it doesn't call the function. So I can also use it like a regular dictionary here. So if I go ahead and put Jenny's number in, and we'll go ahead and give her the information number. So there's my default dictionary. If I try to look up her number now, it does not call the default factory because we've already got her number in there. It's just if I try to put it in, if I try to look it up and it's not there, it'll call the function, put it into the dictionary and return it to me. So that's what a default dictionary does. Okay. So we often use that for, at least the place that I use it for is when we want to group things and we want to know, we want to group them by some kind of a key. So let's say we've got a list of dictionaries and I'll just do a, I don't know if this is going to be, that's going to be ugly. So let me not do that. Let me do a, I'll just do a list. Goodness, come on, don't be helpful. Let's see, I'm just trying to think. Oh, I got it. Okay, so we're going to have an item and the quantity that were purchased. And these will come in as tuples. Actually, this will be easier if I just do it with a triple quoted string. So hopefully this won't be too crazy looking. So apple 5, pear 2, fig 1, pear 6, apple 3, banana 1. Okay, so don't worry too much about how I'm getting this list of lines. Oh, and I want to not have that empty line on the end. Actually, you know what? Here. I'll just strip removes leading and trailing white space. So I'll strip it and then I'll split it on new lines. And then for, so let's say I want to have total needed is going to be a default dict. And its default factory is going to be some function. Crud. Numbers is not good. So Amlia.
Who's that person? I've never heard of them.
Sorry?
Who is that person? I've never.
Oh. So what I want to do is just keep the, I want to see who's ordered what. So I know, when I bring the apples, who do I give them to? So what I can do here is I can say my default factory, and I don't have to call it default factory. I can call it anything. My default factory is going to be an empty list, right? So now I can say for order in lines, I'll call this fruit, and person is, make it line in lines, and then total, sorry, make this orders for a fruit dot append the person. Okay. And now I look at my orders, and what it's done is it's grouped everyone who ordered apples, everyone who ordered pears, everyone who ordered figs. Amlea. Oh, whoops.
It's fine.
Okay, there we go.
It's fine.
Okay. So anyway, that's what default dictionaries are oftentimes used for. You can group them in this way. Now, this particular function right here is kind of a silly little function. The function is always called with no arguments, but it's a simple one-line function. Turns out we can do this. If you call list with no arguments, you also get an empty list. So most of the time, if I was going to do this for real, what I would do is I would say instead, whoops. That orders as an empty dict, or sorry, as a default dict with list. And it works like that. Okay, so that's default dictionaries. They're dictionaries that never raise exception, or that never raise a key error. You can do this with a regular dictionary. You would just have to first check to see if the fruit was already in the dictionary or not, because you'll do something different. You'll either put in a value with an empty list before appending to it, or you will append to the existing list that's in the dictionary. All right, so, and the other one, let me do counters before we do dex. We've talked about dex a little bit before. So a counter is just is a dictionary that counts. What did I call this? Yeah, okay. That was, okay. So dictionary or counters are very similar. Yeah, they're very similar to default dictionaries if you assume that the default value is going to be 0. So I can say, if I go back to this example, and instead of just the people, I wanted to have, here, I'll just copy that whole thing. I wanted to have the counts, so 3 apples, 2 pears, 1 fig, 5 whatever, yeah, pears. And that's my value right there. Then what I can do is I can say for line and lines, fruit, and I'll call this S count is line dot split. And then the actual count, I've got to convert that to an integer. And then what I can do is, sorry, I can say to order is going to be my counter. To order fruit plus equals the count. And what it does is it just sums up all of the apples, right? So it comes up upon the apple 3, and it goes ahead and sticks an apple 3 in to that counter. And then it comes up with an apple 1, and it just increments that. So it knows whether to increment or not. We can also do, if we have, add stooges, right? So if you've got a sequence, we can also count how many of each item are in there. So if you just give it a sequence, it'll count those things up. And we could even find out who's the most common stooge. Mo with a count of 3. So there's other little things that you can do with counters. But those are probably the ones that you might use. And then the other one, the deck. And we talked about this last week or 2 weeks ago. Lists are fast. Actually, let me give you a list. Do it with 10,000, right? So list.append. Let's do a time it. This is kind of awkward. Oh, actually, this is not too bad. So I'm going to do a self-reversing type thing. So this is going to be relatively fast. So I'm going to append a value, and then I'm going to pop it off. Pop removes and returns the last item of the list. So 216 nanoseconds to do that. On the other hand, I could try to do an insert 5 at position 0. That's the right way to do that, right? Oh, sorry, it's the other way around. A 5 at position 0, and then I can also pop off a value by its position. So we'll see how long that takes. And this is, again, 10,000. So 6 microseconds, right? So that is, what does that come out to? 30 times slower. And it's because of the way that lists are laid out in memory that if you try to insert and remove at the beginning, it's got to shift all the 10,000 items each time you do an insert or remove. So And here, decks have a specialized specialized way of doing this. So instead of append and pop, those are going to be fast. Actually, lists are not slow at that. They're slow at that. So they can still do appends and pops just as fast as lists, or they should be able to. Yeah, 212 nanoseconds, right? So about the same speed. But what decks have is they have an append left. Sorry. And that's the same thing as an insert 0. And they have a pop left. And this should be roughly the same speed as the append and pop. It's running at many extra times. Yeah, 212 nanoseconds, exactly the same amount of time. So that's why you might use decks. Let me actually just put this. Okay, so if you think this is going to totally mess people up who come from right to left writing cultures, where the beginning comes at the right and the end comes to the left. So if anybody's primary language is Hebrew or Arabic, I apologize. It's not going to make sense with the left here, but anyway, it works for all Latin languages anyway. Yeah, so the difference there, obviously the deck's much faster. Decks take up more memory. That's why you might not want to use a deck. That's why they're not built in, because the size difference is substantial. But if you are going to be needing to do operations at either end of the collection, that's why you might want to use it.
So if you want to update a set, let's say that's already sorted, and add in a new value that would be somewhere in the middle.
Sets aren't sorted. Let me just make that clear.
I understand an array, I guess.
Oh, okay. Yeah.
Yeah, I just mean like, a list or a deck or whatever. You would use the list though, so that you can kind of insert it in the middle, or?
Yeah, inserting into a sorted array is going to be relatively slow, or inserting into a sorted collection. There are data structures in some languages that make that operation somewhat fast. But Python doesn't use them. So what would be the fastest way to do that is if you had a binary tree that you didn't care whether it became balanced or not. If it was balanced already, then finding where you insert it is really fast. So in Python, you'd probably use the bisect module to find your insertion point, and then you would just use the list insert, because Python doesn't have trees built in. And trying to build a tree is in Python is probably going to take up, like, once you get done with it, the fact that it's written in Python is probably going to make it slow. So.
Okay. So just don't do that.
Yeah, Python's not great at modifying sorted data structures. It's okay at modifying half sorted data structures, so heaps are really good. That's when you don't need to know the full sort, you just need to always be able to find the smallest item. Then you can do that very quickly, and that's in the heap queue module to do that. Okay. Yeah, so those are some of the data structures. Any other questions about list sets, tuples, decks, default dicts, and counters? So if you like the stuff in the collections module, it also has named tuples, which are like tuples, but you can give names to the slots. So you can have a named tuple that always has 3 elements, and you always call them like first, last, social security, something like that. So that allows you to give some names there. That's pretty much all that it does beyond what a regular tuple does. And there's also something called an ordered dictionary, which we don't really care about. It does not sort things. What it does is allows you to rearrange things in a dictionary. So Python dictionaries do almost everything that a default dict does without having to import it from another module. Okay, so that is a brief illustration of some of the Python data structures. And I was happy to see that this actually held up as an example. So between inserting at the beginning and at the end. Okay, so there's also a question about Mongo and what we use it for, why we use it, things like that. So let me get my whiteboard configured here. So let's see, am I drawing? I am drawing, cool. So SQL tables and Mongo. So just SQL has a database, and that corresponds to a database in Mongo. And databases contain, in SQL, they contain tables. And tables are like these collections of rows and columns. And that's kind of like collections in MongoDB. So the main thing about tables is that they have a schema. And no schema by default in Mongo for a collection. So that means your rows of a table all look the same. They have the same columns, right? So you define up front, this table has rows that look like this. And if you try to put a row in that doesn't look like that, it'll give you an exception and it won't let it happen. So tables have columns. And those are kind of like fields or attributes. But we don't really have much of a meaning for those in Mongo because, again, each one of your items in a collection could look different from the other ones. Normally, we don't do that. We have a library that we use called Baron, which makes sure that all of your documents look roughly the same. It's something in Python, it'll enforce a schema because Mongo won't. So then the rows in SQL, I should put a line there too. The rows in SQL are kind of like documents inside Mongo. And so rows are tuple-like. Right, so a row, and in fact, if you read the literature on databases, they actually use the word tuple for row or for a row. So they'll say that a select statement gives you back a result set of tuples. Documents are dict-like. Right? So because each document could have different fields in it, then you really need a dictionary. You can't just go with the positions within the document. The neat thing about those documents, though, is that dictionary could have other dictionaries inside it, right? So databases, or in SQL, our rows are flat meaning that you just have like one, it's a tuple, right? It's kind of flat. The things inside a tuple are typically going to be things like integers and strings and floating point numbers, very simple types of items. Documents can be nested. Okay. So so this is the way that we normally deal with documents. We call it, it makes a really good match for storing JSON. You know, the JavaScript object notation, the thing that we use when we're dealing with APIs. So things that, you know, have like ID is such and such, and attributes has, you know, another dictionary, which is like name, and it's got some name, SSN, and it's got some SSN, right? So that kind of stuff you can store inside a row in Mongo. In SQL, if you're doing this in what we call normalized form, you'd actually do this separately. You would have, let's call this, I don't know, well, maybe this is items. So this is what you could store as a single document, but in SQL, you'd actually have to have two different tables. So you'd have something here, which was the item ID. That would be the only column that you'd have there. You might have other IDs. And then you would have an attributes table, which would have the item ID, the attribute name, and the value. And that's if you only need to go one level of nesting, right? If you wanted to go deeper, then you'd run into other issues. You'd have to have maybe other tables. And this is actually a way that you can be as flexible in SQL as you can be in Mongo. Normally, you're not quite this. Normally, you don't stay quite this flexible. You'd actually say, if you've got a patient, you'd have their last name, first name, social security, all in one row. And that would be very, very kind of brittle. You wouldn't be able to change that very easily. Whereas in Mongo, you want to change it, you know, your documents don't even have to look like each other inside the database. All right. So whenever I wanted to say, and we call this the entity attribute value, because this is the entity, this is the attribute, and that's the value. So that's the most flexible way that you can store things using SQL. But if you need to reconstruct, say, a single entity, then you're going to have to do what's called a join. It's a query that is actually hitting a bunch of different tables, or it's hitting the same table multiple ways. And that can end up being, that can be slow, basically. So anyway, does that make sense in terms of the mapping between SQL and Mongo? Or am I assuming too much SQL knowledge in all of this?
I just have a question. You
Okay.
mentioned Baron.
Mm-hmm.
We're using Baron to enforce schema. If we wanted schema, why wouldn't we just use a SQL database?
Well, the lack of flexibility in SQL is one of the reasons. So being able to use, well, that's part of it, and also the, I guess the way that our schemas work, we can specify things pretty simply inside Baron. Whereas in SQL, you'd have to think about, well, now I'm, you know, what I was using one collection for in Mongo, I now have to use like 5 tables for in SQL because of these kind of relationships. So kind of one of the classic examples that they use is a blog. So I can, so let's see if we got and Mongo. Right, so a blog for both. So in SQL, we probably have an article, right? And we have comments that we want to have. And so this is, I don't even know what exactly they call this particular diagramming that I'm doing, what they call it. But I guess what this tells me is I can have one article, and that article can have 0, 1, or many comments. So sometimes we'll call this a one-to-many relationship, but these are two different tables. We could also have maybe an author, and the author, you're going to have a one-to-one relationship with articles, and you could also have a one-to-one. Let's say you only allow authorized users to comment on your blog. So you would maybe come up with something like this as your schema. So you're going to have 3 tables, and each one of these tables, there's other columns that you'll want to have. Like you're going to have the text of the article, the pub date, whatever. Comments will also have text, pub date. And your authors are going to have like real name, the picture, whatever. Whereas in Mongo, I can store my documents that looks like something like this. Title, pub date, author, which is going to be real name, and pick, and whatever. Comments, and that's going to be a list where I have, the text. Sorry, should actually have the text of an article. And you can maybe have an author here, which has got that author all embedded in there. And we got maybe lots of these, close that off. Lots of these comments. And there's the Mongo document. So this is the way that Mongo would actually store that. And if you wanted to then add a comment, there's an update statement that you can do that will push a new comment onto this list. And so the actual way that it stores it becomes pretty darned efficient for fetching it. Because if you think about, and this was more important when we use rotating disks than it is now, but if you wanted to fetch what's necessary to display on your page, and I'll just put the page right here, right? So we've got the article, we got the article author on that page. We have comments at the bottom, C1, C2, right? So we've actually got to touch all of these pages or all of these tables. And then these have also got potential author information on them, right? So, physically on your disk, again, we don't have rotating disks so much anymore, but you might have the articles over here. You've got the comments over here. And you have the authors over here. And so to assemble what's necessary for this page, you have to go, bounce all around to these different places and, lots of different, we call seeks. And it just means that the things that you need are not stored together. Whereas in Mongo, this is all in one place, right? So if you wanted to display the page, it's a single query to the database. The database has to go to a single location on the disk to give you that article back. So that's the main reason why we would use Mongo over using SQL databases. It makes it really flexible. It's faster to develop, in my experience, than doing things with SQL, even if you got something like SQL Alchemy. So SQL Alchemy is a great library for interacting with SQL databases. It makes a lot of things useful. It provides what's called an object relational mapper. And Baron provides an object document mapper. So the object relational mapper is basically saying, well, the things in memory that you want, you probably want to have something like an article class that's got an attribute for its author, it's got an attribute for its comments, and it's really easy to manipulate that as though it were stored like that in the database. And so what the object relational mapper does is it assembles all the SQL statements that are necessary to build that thing in memory. So it's got kind of a tough job because it's got to do all these joins and everything. That's what we call it. That's the SQL syntax, but it's what it ends up being is seeks on the disk. Object document mapper doesn't need to do as much work, so that's why it was easier for me to write than it was for Mike Baer to write SQL Alchemy. And I think its syntax, well, because I wrote it, I like its syntax better. I like its API better. I won't say that it's because I'm a better programmer or because there's anything intrinsic about it that makes object document mappers easier to understand than object relational mappers. But it certainly is easier to understand for me. So those are, yeah, go ahead.
Documentation for Baron.
Yeah, that can be on your list to do, unfortunately. That's that is something that I have not written. So I did, so when I was back when I worked at SourceForge, I wrote this thing called Ming. And that has docs.
Okay.
Baron, no docs. So that's the downside of using Baron. But there are basically some design decisions that I made in Ming. I didn't like them as much. And so I rewrote an object document mapper, called it Baron, because of course, Prince Baron of Arborea took over the leadership of the planet Mongo once Ming was killed. So that's
wow, that is some deep nerd culture right there, boy.
It is super deep. And the funny thing is, I did not know this when I named it Baron. I did not know where he was from, or at least I didn't remember it. So, but yeah, all into the yeah, the great movie. Say that again. Sorry, you're a little quiet.
So what's that from? I need to look that up.
Oh, that is from Flash Gordon.
Ah, okay.
Oh.
And look at so the movie from the sometime in the 80s. It is horribly campy and it's just ridiculous.
So it makes movies great. Old movies great.
Yeah, so Max von Sydow played Ming the Merciless. And he's like this, I guess, German actor, and he's playing some Asian character. So it's totally culturally tone deaf in all ways. And yeah, his daughter is played by an Italian actress. And she has an Italian accent. But she's supposed, Princess Aura is supposed to be, yeah. Anyway, it's, but it's, if you don't take it seriously, then it can be pretty funny. But yeah. And so that's why, you know, it was the planet Mongo.
Yeah, I just asked because I looked at the docs for MongoDB and PyMongo, and then I look at what we do, and it's a little bit. And so I happened to find Baron, Googling it, and I was like, oh, that's Rick's brainchild.
Yeah. So, you know, it would be good. Like the downside of no docs is, you know, it's harder to learn. And so it makes it harder for people to come up to speed on it. It also means that we really don't have anybody contributing to the project besides me. But it kind of does what we need it to do. So there's very few changes that happen to it on the day-to-day basis. So nobody's asking for changes either. So that's the upside. And another upside is I don't have to spend time writing the docs. But yeah, it's probably good to have them anyway. So at some point, you could look at the documentation for for Ming and see if maybe there's something, to take those same examples and to take the same documentation and rewrite it for Baron would be, I think, a useful thing to spend some time on. So,
Okay.
yeah.
Good to know.
Yeah. And one other thing, this is much less important for us, and it has to do with the way that, so I'll just mention it and then I'll let everybody go. But one other reason, one more MongoDB feature that makes it really nice is called sharding. And you have to pronounce that carefully, because so what sharding is it takes your collection and it partitions it to multiple servers. So and so partition, and this is a partition. So if you need to read or write to that collection, then it becomes faster and it scales better because Mongo can route your query to the right server. And so that means that basically you can handle, if you've got 3 different servers that you're using for sharding and it's well balanced, then you can handle 3 times the traffic. At least that's the theory behind it. There's some overhead involved in routing those queries, but that's the basic idea. And MongoDB, you basically tell it which collections you want to shard and what your shard key is going to be. So how is it going to route those queries? And then it just figures out where to place different chunks of your collection based on those rules that you give it. And it tries to migrate them to the right place and balance things out. Mongo actually has, it has sharding and replication built into it. So technically speaking, what you probably have is shard 0, shard 1, and shard 2. And each one of these are not represented by a single server, but it is a replica set, is what we call it, which is typically 3 servers. And that's mainly for redundancy, and it gives you some efficiency, but also it's just data safety, right? If your server gets killed, you don't want to lose your data. And so you can actually have things set where your reads are allowed to go to any one of these replicas. Your writes are always going to go to a single, what they call the primary one, which can be different. They can fail over, and your writes are always going to go to one, and then those writes are going to be replicated to the other 2. And if you want to, you can tell it that it's okay to read from the others, but the stuff might be slightly out of date if you do that. That's the downside. So in other words, this would be something that would be a fantastic problem for us to have. And actually I have to get good at sharding, because that would mean that we have so much data and so much traffic that we're just not able to keep up with it. We're not there yet. So that's why I focused almost everything on the ease of development and not much on this feature, which you can shard, you can partition SQL databases, but it involves a lot more work, a lot more manual setup to make it work well. But anyway, and there's a book that you can get on some of the different schema design patterns for Mongo. And I actually have a few. So when we get together in person, I'll actually hand off one of these. Well, I have, I mean, they give the author what I still have 1, 2, 3, 4, 5, 6 copies of that one. And a whole lot more copies of the new version of Essential SQL Alchemy, which I had nothing to do with, except writing the first version of Essential SQL Alchemy.
So all of this to say, MongoDB has web scale.
It is web scale.
It is web scale.
Yes, we can end with that.